Okay, well here's an explanation of number 34. And 34 is the asteroid. And the way the asteroid works is when it's parametric, it's written in terms of theta, but really it doesn't matter if it's theta or t or any variable. X is dependent upon theta and y is dependent upon theta. Theta, it's not like a polar function where theta is the angle at which it's moving. It actually turns out a little bit that it's the case here, but you don't have to worry about that too much at all. So basically, when theta equals 0, x will be a. So this coordinate right here is at a, the x value of a, and at theta equals 0, y equals 0. So this is the coordinate a0 right here. And then this is, by the time you get to pi over 2, x is 0 and y is it just happens to be traveling this way. Y is a, and then by the time you get to pi, by the time theta equals pi, x equals negative a, and y equals 0, and then at 3 pi over 2, you're here. But one thing you'll notice, there's a lot of symmetry in this graph. So really, if we want to find the area inside this entire asteroid, all we have to do is figure out the area in terms of one of the 4 sectors of the asteroid. And this sector here, this in the first quadrant, happens from when theta equals 0 to theta equals pi over 2. One thing to keep in mind, well, is the direction of travel. Because as I'm going along this is the direction that this graph is getting drawn. It's going around this way. So if I'm integrating from theta equals 0 to theta equals pi over 2, one thing to notice is that x is getting less. That means that dx is going to be negative. And that is going to impact our answer in some way. We do have to be aware of that because dx will be negative. Because what we'll be doing in this one sector here is we'll be finding areas of these rectangles in this sector. And if we want to figure out the area of each rectangle, well, it's going to be the height of the rectangle, which is going to be a y value, and times the thickness of the rectangle, which is a dx. And we're going to be summing those up along this stretch right here. So we're going to be doing the integral of y dx. And if we look here, well, we've got y right up here. And then we've got x equals a times the cosine cubed of theta. Well, if that's true, then dx is going to equal 3a cosine squared theta times negative sine of theta d theta. Or if we simplify that, negative 3a cosine squared of theta sine theta d theta. So if we sub in that into our equation here, this integral of y dx, we'll get the integral of a sine cubed theta times negative 3a cosine squared of theta sine theta d theta. I'm running out of room. Sorry about that. And what we can factor out of here, we can factor out of this entire integral negative 3a squared. And then we'll have the integral of, let's see, sine to the 4th of theta cosine squared of theta d theta. And this is kind of a pain, this integral. If you think back to our unit on trig methods, trig integral methods, this is probably one of the ones that I didn't give too many of because they're kind of a pain. When both the powers are even, you have to do the power reduction formula, which is that half angle formula, which is kind of a pain in the butt. So what I would do instead, I gave you permission to use your calculators. And if you use a calculator, you get a decimal for this answer. excuse me, we didn't look at the bounds. Oh, the bounds are going to be, well, we're integrating with respect to theta, and theta started at 0, and theta went to, let's see, pi over 2, right? So I'll integrate this from 0 to pi over 2. Yeah, so if you can use your calculator to figure this out, you'll get a decimal answer. If you go to Wolfram Alpha, you can do it, and it will come out kind of pretty. But if you leave the a squared out of it and tack that on at the end, you'll get the answer. And if we do this out, this integral, we'll get negative 3a squared pi over 32. Now, we got a negative answer again because the dx was negative here. So really, when we're getting a negative answer for this area because we're finding the area of one of these rectangles here, and the y value is positive, but this dx, since we're heading left, was negative. So a negative times a positive is negative. So since we're finding area here, we can just kind of ignore this negative because we're finding the absolute thing. And this is just the area of one of the 4 quadrants, this area right here. So if we want to find all 4, well, we'll multiply this by times 4. And then we will get 3a squared pi over 8, which is the area of any asteroid of this shape. So, but yeah, this integral is definitely a pain. Yeah, I did give you permission to crank it in your calculator. But again, you can crank it in your calculator and just leave the a squared out of it and tack it on at the end. And that'll give you a pretty good approximation in terms of a. You can get it to a bunch of decimal places. So there, hope it helps. Thanks.